So in this video, we'll take a look at what displacement is, learn how to calculate it, both in word problems and on number lines. Displacement is defined as how far an object moves in a particular direction. The frame of reference is the starting position of the object, not the object itself. If I say I walked 10 meters to the right, that means I'm 10 meters to the right of where I started. It's not so much about how far I have traveled, but how far away from my starting position I am. Displacement relies on direction. As a result, the direction you move cannot be ignored. This makes calculating displacement a little bit more difficult than calculating distance. For linear motion, components of motion in the same direction can be added together. Components in the opposite direction are subtracted. Let's take a little look at how that works. Robert's walking his dog. He walks 2 meters east, then 5 meters west, as his dog looks for a place to do his business. What is Robert's displacement? What we have here are components of motion that are in two different directions. We have a component of motion that is 5 meters west and a component of motion that is 2 meters east. Because these two components of motion are in opposite directions, we'll end up subtracting the two in order to figure out our displacement. The way I always tell students to do it is just take the larger number minus the smaller number so that you end up with a positive answer. When we subtract 5 meters and 2 meters, we get 3 meters. There will have to be a direction on this answer, and the direction will be the same as your larger component. So 5 meters west is my larger component, so my displacement ends up being to the west. If these two had been in the same direction, we would have added them together, and obviously the direction for my answer would be the same as those two components. Again, in the same direction, you add them together. In the opposite direction, you subtract them. The direction for your final answer when you subtract is going to be the direction of the larger component. Positive and negative signs can be useful in this. You can use them to indicate the direction of each component in your displacement. You take directions like right, east, north, and up and assign positive values to those. You take directions like left, west, south, and down, the opposite, and assign negative values to those. When you use those positive and negative numbers, don't worry about adding or subtracting. The positive and negative signs will take care of that for you. You'll just simply add everything together with their appropriate signs. So we go back and take a look at the same question, Robert walking his dog. My 2 meters east, because it's east, will be positive 2 meters. My 5 meters west, because it's west, will be negative 5 meters. And all I'll do is add those two components together with their signs to find my answer. Positive 2 plus negative 5 equals negative 3 meters. And the negative sign is just telling you that that is to the west. So 3 meters west, same answer we got last time, is the answer that we get this go round. Again, north, east, right, up, those are generally given positive values. West, left, down, south, those are all given negative values. Make sure that you include them when you do the addition so you'll get the correct sign on your answer indicating which direction you've ended up. This answer 3 meters west, no matter how we get it, is not how far Robert and his dog walked. This is not a distance. The frame of reference is not the object in motion. What it's telling us is that Robert and his dog ended up 3 meters to the west of their starting position. Again, the frame of reference is the starting position. Number lines can be used in displacement problems, just like they can be used in position and distance problems. Again, because direction matters, the sign cannot be ignored. You can calculate delta x for each component of a motion. To find delta x, you'll take the final position minus the initial position. Subtract the starting position from the ending position. It's the same way that you would find a change in x or a delta x when you're doing a slope calculation. It's the x coordinate that you ended at minus the x coordinate that you started at. So here I have an object that's undergoing motion. There are 4 different components of that motion. Our object, we're going to assume, starts at 0 and moves over here to position 1. Then it moves from position 1 to position 4. Then it moves from position 4 to position -4. And then it moves from -4 to -2. We're going to calculate the displacement. And again, we're going to do it using that equation, delta x equals the final x position minus the initial x position. So for our first component of motion, we ended at 1, so this is xf. We started at 0, so that's xi, so it's 1, positive 1, minus 0, or a component of plus 1. For the next component, we go from positive 1 to positive 4. So again, take your final x position, positive 4, minus your initial x position, positive 1. Positive 4 minus positive 1 is positive 3. Now we're going to go from positive 4 to -4. And again, when we do that calculation, it's where we ended, -4, minus where we started, positive 4. -4 minus positive 4 is -8. And finally, we're going to go from -4 to -2, so it's going to be -2 minus -4. And -2 minus -4 is positive 2. Now to do our displacement, again, we're just going to add these things together, and we're going to add them together using their signs. So positive 1 plus positive 3 plus -8 plus positive 2. Generally, if you're just doing this without a calculator, you're going to take your positives and add them together first. So 1 plus 3 is 4, plus 2 is 6. So we have positive 6 plus -8, because it's a displacement of -2, or 2 units to the left. Again, this is the mathematical approach to it. This is how you would do it if you were trying to keep track of all your distances in each separate component of motion. There is a good way that you can go back to your number line and make sure that that is the correct answer. And that is simply to look where you ended up on your number line. When all was said and done, we ended up at -2, and our calculation was -2. We are 2 units to the left of our starting position.